Hello students, welcome to the Quick Solutions All India AIATS Test Series JEE Advanced 2020 Test 1A Paper 2 Physics. Let's go to question number 1. Question 1 says, a uniform solid right angled cone of mass m equal to 1 kg is placed on a sufficiently rough surface to prevent sliding. A horizontal force F equal to 10 Newton is applied at the apex of cone if N1 and N2 are the normal reactions on left half, that's 1, and right half, that's 2, of the cone from ground, then take G equal to 10 meter per second square. Option A says N1 is 0, option B says N2 is 5 Newton, option C says N1 is 5 Newton, and option D says N2 is 10 Newton. We have to evaluate each of these four options, which ones are correct and which ones are incorrect. It's given that the friction is sufficient to prevent any sliding of the cone, and we have to determine values of N1 and N2. Essentially, we have to evaluate the values of N1 and N2. The concept involved here is rotational equilibrium as well as the translational equilibrium. So let's draw the free body diagram, in which we will also show the line of action of forces acting, so that we can evaluate rotational equilibrium by calculating torque also. So if I draw, well, this angle is 90 degree, half angle is 45 degree, it's given its right angle cone, so the apex angle is 90 degree. Let's draw something like this. The force F of 10 Newton is acting here. Its weight will be acting symmetrically and its mass is 1 kg, so its mg is also 10 Newton. Because of this force, obviously the normal reaction is shifting towards right. Let's say the effective normal reaction is passing through this point. Let's call it N. The vertical translational equilibrium, the value of N is 10 Newton again. It will balance this mg friction. Now let's say take torque about this point. These 2 points, let's name them A and B. So if we take torque about point B, what do we get? Torque about point B is 0 for rotational equilibrium, which means that 10 into height h, if this height is h, and since this angle is 90 degree, so half angle is 45 degree, this is also 45 degree, so h and r, they have equal value. R, the radius of the cone, is equal to its height. So if we take torque about point B and put it to 0, what do we get? We get 10 into h plus 10 Newton, let's call this distance as x, equals, this is the clockwise torque, the anti-clockwise torque will be 10 Newton multiplied by r, or which is simply h. This clearly means that x is equal to 0. That means the entire normal reaction has shifted to point B effectively, and the value of this normal reaction is clearly 10 Newton. Let's look at the options again. N1 is 0 will be correct because there is no normal reaction in the left half. So N1 is 0 is correct. Option A is correct. N2 is 5 Newton. This is not correct. N2 is 10 Newton is correct. So for this question, options A and D are correct. Let's move on to the next question now. Question 2 says, a bead mass m, which can slide freely on a smooth horizontal rigid rod, and a point mass m are connected at the ends of an ideal string of length L. If point mass is released from the position shown in figure and it performs motion in a vertical plane, then option A says motion of bead will be oscillatory. Option B says velocity of bead with respect to point mass when string becomes vertical is 2 root GL. Option C says maximum tension in the string will be 5 mg, and option D says minimum tension in the string will be 0. Well, the concepts involved are from the topic system of particles. So let's evaluate the options now. Motion of bead will be oscillatory. Now once this particle is released, let's see what all things happen here. So obviously this particle, the point mass, will start falling, and at some time, let's say this is the bead and this is the position of this point mass. This also has mass m. This length is L. Now on this system, if we consider that this bead, the string and the particle of mass m, they form a system, then on this system there is no external horizontal force, which means the momentum will be conserved in horizontal direction, number one. Number two, there is no displacement of center of mass in horizontal direction. Okay, so motion of bead will be oscillatory. So what will happen is, further as the particle comes down, the bead is moving towards right initially. As the particle starts going up, the bead is moving towards right. So the particle will also be oscillating and the bead will also be oscillating. So motion of bead will be oscillatory is the correct option, clearly. Let's look at option B now. Option B says velocity of bead with respect to point mass when string becomes vertical is this much. Well, here we will apply the concept of conservation of mechanical energy as well as the conservation of momentum in the horizontal direction. Now when the string becomes vertical, the loss of potential energy is mgl, which means we can write mgl equals, now this loss of potential energy is effectively converting into kinetic energy of both the bead as well as the point mass. And when it becomes vertical, the point mass, let's say, is going with speed v in this direction. This is going with, let's say, speed v dash. Now since momentum is conserved horizontally and masses are equal, so v dash equals v. That means we can write mgl equals 2 times half m v square. Solving this, we get v equals root gl. Let's look at option B again. It says velocity of bead with respect to point mass when string becomes vertical is 2 root gl. We have found velocity of bead or velocity of the point mass. Both with respect to ground, their magnitudes are root gl. Now since they are moving in opposite directions, so the relative speed of one with respect to the other will become 2 times of this, which means option B is correct. The velocity of bead with respect to point mass when string becomes vertical is 2 root gl is a correct option. Let's look at option C and D now. Maximum tension in the string will be 5 mg. Of course, the maximum tension will come when the string becomes vertical. Now, at that time, if we consider, we have already found the speed v. In the reference frame of the bead, the particle will perform a circular motion, right? At that particular instant, the acceleration of the bead is 0. So the reference frame attached to the bead is an inertial reference frame. Velocity of the particle with respect to the bead becomes 2v. And if we apply the concepts of dynamics of circular motion, what do we get? We get tension minus mg is equal to m into v relative, that means 2 root gl square upon r. R here is L. Solving this, we find that T when the string becomes vertical is 5 mg, and that's the maximum tension, which means option C is correct. Let's look at option D now. Minimum tension in the string will be 0. It's a correct statement. In fact, at the time of release from its horizontal position, the tension in the string will be 0, which means option D is also correct. Let's now move on to the next question. Question 3 says, a uniform chain of mass m and length L is released at t equal to 0 from height L from a horizontal surface as shown. Assuming fallen portion of chain does not bounce, or form any heap on surface, choose the correct options regarding force F exerted by floor on chain at values of time mentioned. And option A says at just before t equal to 2 root L by G, F is mg. B says at t equal to root 3 L by G, F equals 7 mg by 2. Option C says at t equal to root 3 L by G, F equals mg by 2. And option D says at just before t equal to 2 root L by G, F equals 5 mg. Let's evaluate each and every option. We can find the force applied by the chain by using the concept that the force applied is also equal to rate of change of momentum. And another point, let's get it very clear. Like, let's say some part of the chain has fallen. Now, if that is the case, let's say that some part of the chain has fallen and some part is still vertical. So the force applied by the chain on the surface will come from both the parts. The part which is already fallen will apply a force equal to its own weight, and the force applied by the falling part we can find by applying the concept of force equals rate of change of momentum. Okay, so to find the force applied by the falling part, let's consider an element of the chain which is at distance x from the surface. Now it's a free fall, so when this particle is striking the horizontal surface, the speed of the particle with which it strikes the horizontal surface is v equal to root 2gx. Let's consider a very small time interval dt. So the momentum imparted by the falling part, let's call it delta p, is equal to mass which has fallen. That mass will be equal to speed v lambda into dt. This is the mass, its speed was v, so its momentum was this into v. To find the force by the falling part, we divide this by dt, and so we get force by the falling part equals v square lambda, or that means it's equal to 2gx into lambda, where lambda is m upon L. The force by the part which is already there, let's call it the force by the part at rest, is equal to, well, if this is this element has come here, that means the length which is now resting on the surface equals x minus L. So it is lambda into x minus L into g. And expression for force when the chain is falling is F equal to Ff plus Fr, force by the falling part plus the force by the part at rest, and that is equal to 2mg x by L plus mg by L into x minus L. Simplifying, we get F equals 3mgx by L minus mg. Of course, L is less than equal to x is less than equal to 2L. Now let's look at option A. Option A says just before t equals 2 root L by G. Well, at this time, t equal to 2 root L by G, the last particle is striking the horizontal surface. So that means here x equals 2L, and we put it here. What do we get? F equals, if I put x equal to 2L, it's 6 mg minus mg, or 5 mg. So option A is clearly incorrect. Let's look at option B. It says at t equal to root 3L by G, F is this much. Let's find the value of x. When t equals root 3L by G, then x is half G t square, or 3L by G. That means it's equal to 3L by 2. If we put x equal to 3L by 2, what do we get? We get F equal to 3 mg by L into 3L by 2 minus mg, and that means it's equal to 7 mg by 2, which means option B is correct, which also means option C is incorrect. And let's look at option D again. It says at just before t equal to 2 root L upon G, F is 5 mg, which we had found earlier. So option D is also correct. So for question 3, options B and D are correct. Let's move on to the next question now. Option 4 says a glass capillary tube is of the shape of truncated cone with an apex angle alpha so that its two ends have cross sections of different radii. When this tube is dipped in water vertically, water rises to a height h centimeter. Assuming surface tension S equals 10 to the power minus 2 Newton per meter, density rho equals 1 gram per ml, and G equals 10 meter per second square, angle of contact theta is 30 degree, alpha is 60 degree, and radius of capillary tube at upper level of water is 1 upon 10 centimeter. Choose the correct options. The options are: A says H is 0.1, option B says H is 0.2, option C says if alpha decreases then H will decrease, and option D says if alpha decreases then H will increase. Well, clearly the question is from the section Mechanical Properties of Liquids, from the topic Surface Tension. So let's write the expression here and let's make a drawing also. If I draw the liquid surface, this is the surface of cone. The liquid surface is, let's say, something like this, and if I draw a tangent here, this is the angle of contact theta, whose value is given as 30 degree. Let's say the vertical line is like this, and this angle will be, because this angle and this angle are equal, they will both be equal to alpha by 2. That means they are alpha by 2, which is 30 degree. This is the liquid surface. Let's draw a normal to this tangent on the liquid surface, and here is, let's say, the center of curvature of this spherical surface of liquid. So if the radius of curvature of the surface is capital R and radius of tube here is small r, then we can see that this angle equals theta plus alpha by 2. That means we have r cos theta plus alpha by 2 equals small r, the radius of the tube. Now let's consider the variation of pressure. The pressure decreases here across a concave surface. So decrease in pressure is 2s by r, and this is compensated by rho gh. So this is equal to rho gh. So the value of h is equal to 2s by rho g capital R. But as we saw, capital R can be written as small r divided by cos of theta plus alpha by 2. We put all the values here. That means 2 into 10 to the power minus 2. Cos theta plus alpha by 2 is cos 60 degree. So this is 1 by 2. Rho in SI units will be 10 to the power 3 units, and G is 10. So it's 10 to the power 4 into R, which is given as 1 upon 10. And this is 10 to the power minus 2. This is in meter. The value of H, to get it in centimeter, we multiply it by 100. We find H equals 0.1 centimeter. Let's look at the options again. Option A says H is 0.1, and we have to find the height. H centimeter is the height. So value of H is clearly 0.1. So option A is correct and option B is incorrect. Let's evaluate option C and D now. Option C says if alpha decreases then H will decrease. Well, in expression for H we see that we have h equals 2s cos theta plus alpha by 2 upon rho gr. So as alpha decreases, we can see that h increases, which means option C is incorrect and option D is correct. So for question 4, options A and D are correct. Let's move on to the next question now. Question 5 says a spring length L of spring constant K equal to 28 upon 255 Newton per meter is cut into two parts of length L by 3 and 2L by 3, and these two parts are connected with sphere of mass m equal to 1 kg as shown. At time t equal to 0, a very small impulse is provided to the sphere, so that sphere starts pure rolling with v0 as the velocity of its center in horizontal direction. If at t equal to t0, elastic potential energy stored in the spring is maximum, then options are value of t0 may be pi by 2 second, value of t0 may be pi second. Option C says at t equal to pi second, acceleration of center of sphere is 0, and option D says at t equal to pi by 2 second, acceleration of center of sphere is maximum. Well, for solving this, first we find the spring constants of the two parts. Let's say the spring constant of smaller part we represent by option K1. So since the length has become 1/3, so K1 will be 3 times of K, and that means it is equal to 28 into 3 by 255 Newton per meter, which is equal to 84 by 255 Newton per meter. The other spring has twice the length of the first spring, and so its spring constant will be half of this. That means we can say K2 equals K1 by 2, and its value is then 42 divided by 255 Newton per meter. Now let's say consider that the sphere is oscillating with a small angular amplitude. Let's consider oscillation about this point. So if it has turned by small angle theta, then what is the restoring torque? We can see that is equal to, let's consider torque by the first spring first, the spring of force constant K1 first. So if it has turned by angle theta, the force is K1 into R plus R by 2, that means 3R by 2 into theta, that's the force, multiplied by 3R by 2, that's the torque. Similarly, by the other spring, its force constant is K1 by 2, so let's write it as K1 by 2, and if it has moved by angle theta, then the force constant multiplied by 2R theta, and if we multiply it by 2R again, we get the torque. We put a minus sign because it's a restoring torque. The torque is I alpha, and so I here is, it's a sphere, so I about this axis will be 2 by 5 mr square plus mr square, that means 7 by 5 mr square into d2 theta upon dt square is equal to minus K1 r square by 4 into, within brackets, into theta. Simplifying, we get d2 theta upon dt square equals minus 17 K1 by 4 into 7m into 5 into theta. This means omega, the angular frequency for oscillation, can be written as under root 85 K1. Let's put the value of K1 is 84 upon 255, and then here we have 28 into m, which is 1. Let's simplify it further. We'll find that value of omega turns out to be 1 radian per second. And this means the time period of oscillation is 2 pi by omega, that means 2 pi second. Okay, so we have come to an important point for solving this question. Now it's easy to evaluate the options. So let's look at the option A again. It says value of T0 may be pi by 2 second. Let's see what was T0. T0 was the time at which elastic potential energy stored in the spring is maximum. Well, elastic potential energy stored in the spring is maximum when the angular displacement of the sphere is maximum from its equilibrium position. Now that will happen at time small t equal to capital T by 4, or this will also happen at time t equal to t by 4, or then again at 3t by 4, and so on. So option A, if I say t by 4, the value of t by 4 is pi by 2 second. That means option A is correct. At time t0 equal to pi by 2 second, the sphere will be at its extreme position where the potential energy stored in the springs is maximum. So option A is clearly correct. Value of option B says now value of T0 may be pi second. Well, at pi second, that means at t equal to capital T by 2, it will be in the equilibrium position, and at that time the potential energy stored is 0. So option B is an incorrect statement. Let's look at option C now. It says at t equal to pi second, acceleration of center of sphere is 0. This is correct because the sphere is passing through its equilibrium position. So option C is also correct. And option D says at t equal to pi by 2 second, acceleration of center of sphere is maximum. Well, at t equal to pi by 2 second, it's at the extreme position, and at the extreme position, center of sphere will clearly have its maximum acceleration. So option D is also correct. That means for question 5, options A, C and D are correct. Let's move on to the next question now. Question 6 says a particle of negligible mass lies on a fixed inclined plane PQ, which makes an angle alpha with the horizontal. Two forces F1 vertically downward and F2 horizontally act on the mass as shown. Assuming the particle remains stationary, choose the correct options. F is frictional force. Well, situation has been described with the help of a drawing as shown here. Option A says if mod F1 equals mod F2 and small f equals 0, then alpha is 45 degree. Option B is also about the frictional force. Option B says if mod F1 equals mod F2 and alpha is greater than 45 degree, then direction of frictional force on the block will be toward Q. Option C says if mod F1 equals mod F2 and alpha is less than 45 degree, then direction of frictional force on the block will be toward P. And option D says if mod F1 equals mod F2, then F equals 0 for all values of alpha. Let's evaluate these options. Obviously, the question is from the topic laws of motion, and the subtopic is friction, for which we draw a free body diagram of the particle whose mass is negligible. So if I draw the free body diagram of the particle, the force F1 is acting vertically downward, force F2 is acting like this. Let's say this is the surface PQ and this angle is alpha. If this angle is alpha, then this angle is also alpha, and this angle is 90 degree minus alpha. Let's evaluate option A now. It says if these two forces have equal magnitude and frictional force is 0, then alpha is 45 degree. Well, if the friction force is 0 and the two forces have equal magnitude, well, for equilibrium we will have F2 cos alpha equals F1 cos 90 degree minus alpha. That means F1 sin alpha. If friction is 0, for equilibrium this condition must be satisfied. Now if F1 and F2 have equal magnitudes, that means we have tan alpha equals 1, and which means alpha is 45 degree. So that means option A is clearly correct. Let's evaluate other options now. Option B says if the two forces have equal magnitude and alpha is greater than 45 degree. If this angle is greater than 45 degree, this angle will be less than 45 degree. That means if we look at the components of F1 and F2 along the incline, the component of F1 along the incline in the downward direction, the component of F1 down the incline will be greater than component of F2 up the incline. That means for equilibrium, friction will be acting up the inclines, that means in the direction towards Q. So which means option B is correct, right? The frictional force here is clearly for equilibrium, static frictional force, and it will act such that it opposes the tendency of slipping. Let's look at option C now. It says if mod F1 equals mod F2 and alpha is less than 45 degree, then direction of frictional force on the block will be toward P. Well, if alpha is less than 45 degree, that means component of F2 up the incline is greater than component of F1 down the incline, and so the frictional force to oppose slipping or tendency of slipping will be acting down the incline. So that means option C is also correct. Let's look at option D now. It says if mod F1 equals mod F2, then F is 0 for all values of alpha. Is clearly incorrect. So for question 6, options A, B and C are correct. Let's go to the next question now.